We have another example on the board. Again, I'm going to redraw the circuit in order to make it looking a little bit simpler. So, what I'm going to have, anytime I have 15 volts, it means that I have power supply, right, connected to it, okay, with the positive terminal. This is my voltage source, okay? This is my 15 volt power supply, and basically this is my ground, okay? This is to make a long story short. Anytime you see 15 volts, you're supposed to just imagine that there is a power supply connected to the diode by the positive terminal, and this is my negative terminal. And of course, this is 15 volts, okay? So you can erase this 15 volts, just do not confuse yourself. This is my 15 volt power supply connected to the circuit. So the problem is asking us to find the total current and output voltage. Because I have two resistors, I have to find first the total current. In order to do so, I'm going to first check if my diodes are working, okay? So please notice that the voltage source has the value much greater than 0.3 and 0.7. So these two diodes are going to be forward biased, and my current is going to flow this way. Okay, I said they're going to be forward biased because total current is going to go in the direction which is showed by two arrowheads of my diodes. So please notice that this arrow is going the same direction. So both of them are conducting, so current is flowing. And remember that anytime current is entering component, you're supposed to label that terminal by positive sign. Anytime it's leaving, negative, and I have positive, negative, positive, negative, positive, negative. Now we're going to talk about the voltages across resistor R1 and R2. Don't forget that in order to find the voltage across these resistors, we are going to use Ohm's law. So I can write that VR1 is equal I total times R1. I say I total because in this circuit we are going to have just one current because this is series circuit. And I have VR2 is equal I total times R2. Now, we can say that we are ready to write KVL equation for this circuit. I'm going to start from ground and I'm going to go clockwise. So what I have first, I'm going from this point. I'm seeing negative sign, right? And I'm supposed to write negative voltage source because I have negative voltage source. Now keep going, plus V of the germanium diode, right? We have plus V of the silicon diode, okay? Plus voltage across resistor R1. We said that VR1 is equal I total times R1. Plus I total times R2, because voltage across resistor R2 is I total times R2. And we reach the ground. Everything is equal 0 volts. Next, we're supposed to solve this equation for IT, total current. So I'm going to have I total R1 plus I total R2 is equal, I have to move my Vs to the right side, so I have to change the sign from negative to positive, so I have Vs, and I have to also move VGE to the right side and VSI to the right side because I do not have I total next to them. So I have negative VGE, okay, negative V silicon. Next, you're supposed to factorize I total, so I have I total, open parenthesis, R1 plus R2 is equal voltage source minus VGE minus VSI. I'm doing the long way in order to prepare you for more sophisticated problems which are going to require to use heavy algebra in order to solve them. So I have, in order to find I total, I'm supposed to divide both sides of my equation by the content of the parentheses. So divide them by R1 plus R2, R1 plus R2, R1 and plus R2 and R1 plus R2 will cancel out, and I have I total is equal voltage source minus VGE minus VSI over R1 plus R2, which is equal, voltage source is equal 15 volts minus VGE, which is equal 0.3 volts, minus V silicon, which is equal 0.7 volts, over R1 plus R2. Okay, don't forget about the parentheses. We have 1.2 kilo plus 2.2 kilo. Everything is equal 4.11 milliamps. Okay, so this is the total current in my circuit. Let me repeat myself one more time. I total is equal to I, the current which goes through the germanium diode. This is going to be also equal to the current which goes through the silicon diode. This is also equal to the current which goes through resistor R1, and this is also equal to the current which goes through resistor R2. Everything is equal 4.11 milliamps. So we found the current. Next, we're supposed to find the output voltage. In order to find output voltage, I'm going to write the KVL from output terminal to ground. On the test, always choose the shortest way to reach the ground in order to save the time. So I'm going to go from Vout to ground by resistor R2. So what I'm supposed to write? That Vout is nothing else, just the voltage across resistor R2. Remember, we measure Vout between output terminal and ground. So I can say this is equal VR2, which is equal I total times R2. Okay? So I have I total 4.11 milliamps times R2, which is equal 2.2 kiloohms, equals 9.04 volts. Okay? So this is one way to do it. If you want to verify that your answer is correct, you're supposed to try to find the output voltage going counterclockwise. Okay? This is a longer way, but it's always good to check if you are doing everything okay. So I can say this is other way, right? So I can say this is one way or the other way. V out is equal, let's write the KVL equation for this way. So I have negative sign first, right? So I have negative VR1. Okay, we said that VR1 is equal I total times R1. So I'm going to write negative I total R1 minus V silicon minus V germanium, because I have negative sign first. I'm going this way. Negative voltage across the silicon diode minus voltage across the germanium diode, and I have positive sign over here, right? Plus voltage source. Okay, so this is equal negative 4.11 milliamps times R1, which is equal 1.2 kilo, minus 0.7 volts minus 0.3 volts, okay, that's the transition voltages for silicon and germanium diodes, and I have plus voltage source which is equal 15 volts. Everything is equal 9.06 volts. Please notice that these two values are very close to each other. They're supposed to be equal or very close to each other. So it means that we solved the problem and all our answers are correct.